Back in 2018, researchers at Google AI Language dropped a paper that would completely change the game for artificial intelligence. It introduced a model called BERT, and it didn't just improve on what came before, it totally rewrote the rules for how machines understand human language. So, what was its secret sauce?
You know, the core problem has always been this one thing. How do you get a machine to really get the context, not just the words on the page? Before BERT came along, AI had a pretty serious blind spot.
Okay, so to really get why BERT was such a big deal, you first have to understand the huge problem that was holding everything back. Let's just call it the one-way street problem.
So here's the thing. This slide really gets at a basic limitation that held AI back for years. See, before BERT, models, even really impressive ones like OpenAI's GPT, could only read in one direction, from left to right. But that's not how we understand things, is it? Right? We see the whole sentence. It's kind of like trying to read, but you've got your hand covering up all the words to the right. You're just missing a huge chunk of the story.
And yeah, suboptimal is the exact word the researchers used. And honestly, that's putting it mildly. This one-way street was a huge handicap. Think about it. For something like question answering, where the AI has to find an answer in a paragraph, if the key piece of info showed up later in the sentence, the model would just completely miss it. The paper even went so far as to call this approach very harmful. Clearly, something had to change.
And that, of course, brings us to the solution. And BERT? Well, BERT didn't just find a little detour. It totally reversed the flow of traffic.
So, what is BERT? It stands for Bidirectional Encoder Representations from Transformers. And the magic word there, the really important one, is bidirectional. Unlike everything that came before it, BERT was built from the ground up to look at the entire sentence at once, both ways, left and right, at every single level. It could finally see the whole picture.
And this is where you really see how different it was. OpenAI GPT, like we said, was a one-way street. So you had another model, Elmo, which tried this clever little trick. It trained two separate models, one reading left to right, the other right to left, and then kind of stapled the results together at the very end. The paper calls this shallow, and for good reason. The two sides never really talk to each other. But BERT? Totally different story. It was deeply bidirectional. This means it was mixing the left and right context together through its entire brain, so to speak. It wasn't just getting two perspectives, it was creating one, single, super context-rich understanding.
Okay, so this sounds amazing, right? But wait, it creates a new problem. If the model can see the whole sentence at once, what's to stop it from just, cheating? Just looking at the answer it's supposed to be guessing? Well, the answer lies in a couple of really clever training tricks.
So how'd they pull it off? The secret sauce, as they say, was two brilliant pre-training tasks.
Okay, trick number one is something called a masked language model, or MLM for short. And this quote from the paper really says it all. See, instead of trying to guess the next word in a sentence, which is what older models did, the researchers just randomly hid a few words. They literally put a mask over them. And the model's entire job was to figure out what was behind the mask, based on everything around it. It's basically a super advanced game of fill in the blanks.
Let's make this super simple. You start with a sentence like, "My dog is hairy." The system would then mask about 15% of the words, so you get something like, "My dog is mask." Now, the model has to look at the full context, "my dog is," and predict that the hidden word is, of course, hairy. And because that mask could pop up anywhere, the model is forced to develop a really deep contextual understanding of every single word in the language. But understanding words inside a single sentence is only half the battle. So much of language is about how sentences relate to each other. And that's where the second trick comes in, next sentence prediction. The idea here is actually pretty simple, but it's incredibly powerful. The model gets fed two sentences, let's call them A and B. Half the time, sentence B is the actual next sentence from the original text. But the other half of the time, it's just a totally random sentence plucked from somewhere else. So BERT's job is to just say, is next or not next. By playing this simple true or false game over and over and over, millions of times, it got really, really good at understanding the logical flow and connection between sentences. This is absolutely critical for things like question answering.
Okay, so the theory is genius, right? But the million-dollar question is always, did it actually work? How did it do out in the wild?
Well, the results were, honestly, they were staggering. BERT didn't just nudge the old records, it absolutely shattered them.
It went on to set new state-of-the-art results on 11, that's right, 11 different language tasks, basically all at the same time.
And you can see the jump right here in the numbers. Take the GLUE benchmark, which is kind of like the Olympics for language models. BERT boosted the score by a massive 7 percentage points over the previous best. That's huge. And then there's the squad question answering test. The old champ was this complicated ensemble system, basically a whole team of models working together. A single BERT model came in and beat it, all by itself.
And when you look at it on a chart, the difference is just wow. The best score on the official GLUE leaderboard was sitting at 72.8. BERT comes along and drops an 80.5. Let me tell you, in the world of AI research, a jump like that isn't just a step forward. It's a whole new ballgame. It's a total paradigm shift.
Now, a huge piece of this puzzle was how easy it was to adapt BERT for different jobs. It's a process called fine-tuning. The idea is you take this giant pre-trained BERT model that already has a great general grasp of language, and then you just train it for a little bit longer on a very specific task. Say you teach it to spot if a movie review is positive or negative. And this turned out to be incredibly effective and pretty cheap to do, all things considered.
So let's zoom out. Forget the record-breaking scores for a second. What was the real lasting legacy of BERT? I mean, why are we still talking about a paper from 2018?
Well, BERT completely changed the way people thought about NLP research. First, it proved that to really understand language, you have to look at the whole picture. That deep bidirectionality was the key. It also pretty much ended the era of building a custom, one-off model for every single little task. It showed that one massive pre-trained model could be taught to do almost anything. And maybe most importantly, it kicked off this massive race to scale. It showed that making models bigger wasn't just a small improvement, it was transformative. It basically paved the way for the huge language models we have today.
And this quote from the paper really nails a discovery that was, at the time, genuinely surprising. I mean, everyone kind of knew that bigger models work better on big problems. Duh. But what BERT showed was that a huge pre-trained model could give you massive gains even on tiny little tasks, ones with not much training data at all. The takeaway was crystal clear. Size and pre-training were way, way more important than anyone had previously thought.
So those core ideas that BERT brought to the table, that deep bidirectionality, the massive pre-training, and then fine-tuning for specific jobs, that's the foundation that almost all of today's AI is built on. So yeah, the next time you use a search engine or talk to a chatbot or get a sentence auto-completed, you're basically seeing the legacy of this 2018 breakthrough in action. The question now is, what comes next?